Hello, everybody. I'm happy to be here. Hope the computer works. So, yes, it's up there. I'm going to talk about Kotlin Standard Library today. As I was introduced, my name is Anton. I work for JetBrains, actually for the Kotlin team. And I joined Kotlin team 4 years ago, having about 15 years of Java background by that time. And well, I started learning it, and my assumption was that I'm going to teach Java developers how to write Kotlin code. The reality was slightly different. I started to talk to Kotlin developers, and I'm still learning from the best. So yeah, and the standard library is actually, it's not a huge in Kotlin, but I'm still learning it. I'm still discovering what's new in there. It has been pretty stable for quite some time, but all the stabilization work we did for a couple of years now was related to going multi-platform. So a lot of functions that we made stable existed for a long time already, and well, if you read the release notes, you will see that that function is not now stable for native, that function is now stable for, I don't know, Kotlin.js and so on. I have to give the credit to my colleague who actually works a lot collecting this kind of interesting ideas from Kotlin Standard Library, Sebastian Eigner. He came up with the idea for the talk. I'm kind of stealing it from him, but presenting it to you in my own way. So have you, those who already program Kotlin, has it happened to you that you write some code processing some data, maybe, and you write a nice function that is performant, looks nice, very readable, and then you discover the next day that there is exactly the same function in the standard library already? Happened to you, right? Happens to me still every day. Well, almost. Anyways, when I started to talk to people who already use Kotlin, why they select the language or what do they like in the language, obviously they mentioned nice, concise syntax, null safety, coroutines, the multi-platform capabilities, and so on. But they also mentioned the nice standard library, and it's really nice. I mean, it has so many convenience functions that it's hard to miss. So today, I have a few topics that I select from the standard library. Collections is basically the beating heart of the standard library, and obviously it's something that is immediately useful when you start programming Kotlin, write the application code. Scope functions, you gotta love them, and they are confusing, so we have to spend some time there. Builders is a feature, or let's say a notion in the standard library that is enabled by the scope functions, so we naturally flow there. And well, if we have more time, depending how I show you the samples, we probably will have a few other examples from the standard library as well. We start with collections, obviously, and every time someone talks about collections, they show you this nice diagram from the documentation. Either they show it in the documentation or separately on the slide. I do both at the same time. What is interesting here for us today is that we have lists, sets, and maps. We have transformations between those types. We have some transforming functions for those collection types as well. But one thing to notice is that we have separate interfaces. So if you're just starting with Kotlin, this is something that is going to be maybe not immediately obvious for you, but this is where you have to pay attention to. List is not a mutable list automatically, and mutable list is not immediately immutable for you. Okay, I'm going to start with live coding. I'm pretty bad in live coding, so you have to survive. And then once I see that you're already exhausted, we switch back to the slides and see how it goes there. well, I just show some basic functions, and since I said I'm pretty bad in that, even the team is saying if Anton can type it, it means that it works. Nice. So we start with very simple things with collections, right? If you talk about collections, your favorite data structure is a list, of course. So why not to start with a list? How do you construct a list of values? List of course. I hope it's visible. All right. If we just extract it as a value and maybe print it just for us to see what's going on, as out, run the program. I hope it compiles fast. I probably not even running K2 here, so it's pretty fast by default. So there's the result, right? How can we do the same in some different way? Maybe ask it to rewrite using list int function. So we do the same. And, well, looks good to me, right? So let's remove that. I think it does the same. So let's confirm. Does the same. Nice. I have some notes for myself, so I have to look it up. That's a nice way to construct I don't know, lists, and then you have this index. It's easy to make off by one error there, because you see like you have the index and it starts from 0, and you expect 3 elements. So if you don't account for that, it's going to be 0, 1, 2 instead of 1, 2, 3 that you expected. The same you can do with mutable list if you want to construct a mutable list, right? So imagine we want to play a Wordle game, maybe. Let's create a word of 5 letters and yeah, just return a question mark. So there will be 5 question marks, right? 5 of those. But it doesn't look like one string. Maybe I want to join them. And there's a very nice function called join to string in the standard library. Actually, there are 2 overloads of that. One accepts a list of parameters, and the other one is with transformer function. Let's take this one first, and we want to join by the empty string. We get just 5 question marks as the result. Since it doesn't look yet like a Wordle game, maybe we want to overwrite some of the characters like this. Let's say first character is not 5, let's make it 6. K, and the other one somewhere in the middle of the string is going to be L. So let's try that. What's going to happen? Can you guess the word? Kotlin, of course. Okay, looks interesting. What else is there? Since when we saw the signature of join to string, we saw that there are more parameters. Let's check that. So there is a separator. Obviously, the first character you want to use, by default, it's a comma. Then there is a prefix, and there is a postfix, and there is a counter that allows you to limit how many times you want to join or perform this operation. There is a parameter to define what should be done with the rest of the elements, and there is a transformer function. So let's try to apply all of them at once. So the separator, I love the named parameters. So what was there again? Prefix, let it be something like this. Maybe postfix is going to be symmetrical. We're gonna do it for 3 times limit. What's going on? Comma is missing. limit three times. What else was there? The truncated sequence, maybe truncated, going to be just etc. The separator, different separator. And there is a transformer function, right? What was there? It's here. So let it be something like, yeah, goes uppercase. Actually should be something else. The assistant is not that capable this time. Let's run the program and we see the result, right? Nice. So this function is very convenient for all kind of things like working with strings and so on. In context of this example, of course, it looks like strange to start with question marks and then come up with positions in the string, which one you want to replace. Maybe it makes sense to start with the original word and then replace the characters with the question marks. How could we do that? Maybe like this. So there will be a list. Let it be Kotlin. We want to replace some of the characters. Maybe I would like to replace K and L. Replace. Obviously, we can use regular expressions there. Regexp. Why not? K or L. The ID will tell me, hey, you're doing it wrong. What's there? Single character alternation in regexp, and alt-enter is going to fix that. And just substitute with a question mark. And maybe to list. Looks good to me. How can we verify if it works? There is an alt-enter on the regular expression. You can check the expression and see how does it match. We see that it matches K and L. Looks good to me. And let's see how it works. List and S out. Let's run the program. Yeah, it's there. We didn't join it, but you can imagine all the operations I could take further to achieve the string. All right. Since we are already working with collections, what else could we do? For instance, we work with a list of students, list of names, and you're a professor and you're assigned to break the list of students into pairs. So let's run this randomization roulette, or we want to automate all that. List of students. L, list of names. I do have a live template for that. Val, maybe students, like this. Students. Okay, happens to me. You see, I told you. So how can we break this list into pairs? One of the options is to use the chunk function. So we gotta split them into chunks. Split, chunked into 2, and then let's say we want to print it out. Let's see what happens. So we can see that Anne is with Joe, Max is with Anton, Joy is with Bo, and then there is lonely Ken. Well, if you rerun this function every time for the same input, we get the same output. That is obvious, that's expected. How can we make Ken happy as well to get a pair so that it would be fair pairing all the time? Like first time he's alone, but maybe next time someone will be alone. So we could use this shuffle function, for instance, and then we get a different output every time because it's randomized, right? In fact, this is an interesting place to dive into the implementation. So if you go inside the implementation, it's an extension function on iterable, but an interesting thing is that it's declared as actual. So it tells you that the shuffled function, the original one, is actually a multi-platform. So it's capable to be used in multi-platform, and actually all the standard library is capable for for multi-platform projects. And we dive further, and we see that it's actually using the Java implementation, right? So on each platform, it will be delegating to the native implementation whenever possible, so that it would be the expected behavior. So sometimes it's pretty interesting to dive into the implementation of the standard library functions and see how they actually work, and discover that they actually delegate to the standard library of your platform. The other very similar function for kind of the same purpose is windowed. So for instance, I don't want to split into pairs, but I want to shuffle or like slide through the whole collection of the values, just sliding the window by position, and then I can define which what should be the size of that window. For instance, like this. So 3 students, and let's see the result there. So we can see first we have a window of Ken, Bo, and John, then Bo, John, and Max, John, Max, and Anton, and so on. And these functions are pretty useful. There are a few others that are quite similar. We're gonna get into those as well just in a moment. But I want to show you a few others first. So for instance, we have a list of cities. Amsterdam, Berlin, Tallinn. I'm coming from Tallinn. We are in Amsterdam, and Berlin is just the city. So let's extract that. Let's call it cities. Cities, European cities. The AI assistant knows something for us. Good. Then we have a list of countries. Obviously, they match on purpose. That's by design. And maybe we want to pair them now, right? We have 2 collections, we need to combine them. We know that the positions will match. They are of the same size. What function could we use there is just call cities and apply zip operation with countries. And then, as you can see, it looks like an operation, city country pairs. Looks good to me. It looks like an operation, but it's actually a function. And we can use it as an operator because it's declared as an infix function. And well, it's definitely useful in some situations. And because of the name, I wanted to show another interesting function that is called zip with next. So if we take the list of students, for instance, again, students, and call zip with next, it's going to do pretty much the same as if we are using the windowed function, but with parameter 2 as a parameter. So let's do that. S out and run the program, and we'll see that, well, let's run the window function also with 2. It will then show that it behaves pretty much the same way. But the difference there is that the first one is a list of lists, and the other one is list of pairs. So if we have pairs, then it's pretty easy to do something, apply some functions that are, let's say, can transform it into maps, for instance, right? We zip it and immediately transform into a map. One other thing that is very useful when working with collections are obviously let's just use any collection, maybe int numbers, and it's not the point what values there are right now. We just use the list type here. Fold and reduce standard library functions. Who had the privilege to use them already in the audience? just a few. And the others, well, at some point you will have to use them. Like, you better learn them. But they are very similar. The difference is that fold function is using some initial value as an accumulator. So for instance, an empty string, and the operation produces a string which could be attached to the accumulator, and then you just accumulate something into the string. The reduce operation doesn't have the initial value, it just calculates, applies the operation to two parameters that were selected from the collection, one by one. I will not show an example with those, but instead I want to go back to the slides and show you where you can actually learn more of those functions and see how elegantly they apply to the task that you have at hand. So you know about Advent of Code challenges. Yeah, that's an awesome activity. Every December, starting from the 1st December, they have a new challenge with a couple of variations of the tasks that you have to solve. Seemingly, they are not real-world problems, but if you think a little bit more about this, there are patterns. There are patterns that you will apply actually at your work when writing applications. And well, we spent quite some time in the team implementing those challenges and streaming that to YouTube. So like in the previous years, in 2020, 2021, I think last year, so for 4 years at least we've been running this. I usually survive the first week, and then I have to kind of challenge myself to actually understand what the task is, and I'm demotivated by that. But my colleagues are usually solving it till the end. The point here is that if you go to our YouTube channel, you will find the streams or just the videos explaining how you can solve this task without using any extra libraries in idiomatic Kotlin. And well, sometimes we just for fun apply something else than just pure Kotlin code. Let's say, let's solve it using Kotlin notebooks. How does it look like? How can we visualize it? And so on. So we did that last year. And I selected just one challenge from one of those years to demonstrate how standard library functions start helping us to solve those challenges. So there is a task: count the total of characters that are present on each line in every group of strings. So we have two groups there, first and the second one. Then there are characters that are present on each string. In the first group we have D that is present on each line, meaning that the count for this group, or the result for this group, will be 1. And for the second group it's XYA, XYB, XYC, meaning that the intersection or the characters that appear on every line is X and Y, meaning that the result for this group will be 2. And the total is just the sum of those. So how can we calculate the sum for every input, and how could we solve that? How could we solve this challenge in Kotlin? First in a naive way, and then see how we can transform it into the standard library functions that are already available, and they will reduce a lot of code for us. So there is a string, right? Normally they read it from file. Let's simplify that, assume that we are getting a string. We read in a string, we have to split by the empty line to get the list of values, and then we have to iterate over those groups, right? So each string is representing a group, and a group is a multi-line string. Then we have to transform it somehow into the lists of characters, and then we can iterate over those groups and calculate the result. There you can see the intersect operation for the sets. There are some very useful operations when working with the sets, like finding the intersections between the sets, unions. You can subtract one set from the other one. So if you haven't seen those, play with those and see how convenient it is. Then we have to calculate the final total. So we calculate some kind of result for each group, and then we have to calculate the total. It seems like a very simple task, but and it's not a very complicated code either. But you have to read to understand what it is. It's not declarative. You have to kind of apply some mental effort to interpret what it is doing line by line and so on. So there we can extract or distinguish a couple of operations, right? At first we have to transform the data, and then we have to calculate the result. So how can we transform it, this code, and how can we write it differently using the standard library functions to achieve the same? At first step, we are transforming the data, right? Because it looked like this previously. Let's match the different operations. So first, the iteration usually, once you have a loop, like once you see that you're doing something in a loop, then there is definitely a standard library function that will be looping through the collection of items, pretty much definitely. And then if you need to transform something, then it means we're doing a map. And that's the operation. It stays the same, right? And the type is right there, so we can see the direct relation between different operations. Next, we have this calculating result part of our challenge. Let's map it to the initial implementation. So there is the task that we are doing. We are calculating a total, meaning we have to accumulate something. Like we have this var that is a mutable variable, and that's a pattern. And if you write such code in the IDE, actually if you go to the for loop and hit Alt-Enter, it's gonna offer you to transform it immediately into the sum of function. But here we can see that it all applies, so that we can see the relation between the initial code and the standard library function. And then we have this operation instead of inside, or used as a parameter for the sum of function. And there we have this reduce function that I mentioned before, right? We need to accumulate or like reduce the list of sets to a single set, like that will be the final result, basically used for the final result. And there's our intersect operation, and there's our final solution. So there was this long loop that wasn't very hard to read, but you had to read it and understand and keep in your head what is going on. Here it's a more terse solution. I would say it's very idiomatic, but then you have to know what every function is actually doing and what will be the implication of invoking that, right? But it reads pretty well. We are mapping the groups first into some data structure, and then we calculate the total of that data structure inside the reduce, applying the reduce function. Now, fold and reduce are very, let's say, for the newcomers, they're very unintuitive functions. They start mixing them up, and they don't know how to, like, which one to select, and what will happen if I, like, what are the intermediate operations or intermediate results that I'm getting with this reduce function. In the standard library, we have a very interesting function that probably is not applicable to every project, but I find it very useful for learning the reduce and fold, because you can do list. Let's delete all this. It's just getting in the way. List of numbers, whatever it is. Let's do more. Actually, 4, 5, 6, 7, 8, whatever. And then we want to reduce it, and if we just reduce it like this, just calculate the total, right? A and B, So it's going to slide over the list of elements and give us the two parameters, and we can do with those two parameters whatever we want. And then, for instance, we want to print it out. What will happen? 36, right? Whatever the number is, we are not even checking right now. Is it correct or not? Like, I don't know even like what was my intention right now. Just the final number. But what were the intermediate results? So you might want to add some logging into this lambda, or do something like try to debug those invocations step by step. Instead, there's like a very useful function for this. I think running reduce that will do pretty much the same, but store every step of the invocation into its own result, and then the final result is not just a single number, but actually a list of all the intermediate results. Here it is. I just heard like, it means that it was useful, right? Great. Okay. There are other interesting operations that you can run with for maps. I was just using lists and sets until now. For instance, I'm working with colors. There are some colors in my list. Let's say my favorites. No, yeah, favorites. Favorite colors, whatever. And then maybe a list of other colors. Yeah, maybe I want just to operate with those. Let's keep it like this. And maybe I want to transform it in a way that it's going to map a name of the color to some value. Assume it's going to be a number of characters, or like the length of the string that I'm working with. So colors map, because I'm transforming it into some other data type. Obviously, I'm working with the element. It is the string, meaning that this is the color that I'm using. Assume I'm transforming it to the uppercase, and maybe I'm going to map it to the length of the string. And then, since it's the result is actually the map, right, or the list of pairs, as I said, then what the list of pairs could be, it's basically a map. We can transform it into a map. If we are doing it like this, the IDE will actually tell us that, well, you probably can do it more efficiently. You see the underlined map invocation. So if I hit Alt-Enter there, it's going to tell me, hey, you probably want to merge this chain into associate. So it's not going to call the toMap function anymore. It's more like, let's call it idiomatic way of doing the same. But there we are doing just the transformation, and well, this function is good enough for this case. But in case we didn't transform the original value for the key, let's say I'm not invoking the uppercase here, again the IDE will tell me you can do better. Alt-Enter, you can use the associate with function, and then instead of creating a pair yourself, you're just going to say that whatever the value comes in, map it to something else and use it as a key. Nice. There is also associate by, which is going to be the reverse. It's going to use the integer as a key, and then use the value itself as a value to the map. But in our case, we don't have any red, blue, yellow, violet, black. Let's say we for Yeah. So they are of the same length, right? So what will be the result? What do you think? Something is going to be left out, right? Right. So the violet was there. The yellow is gone. So it seems we could do something else. We could do GroupBy, and in this case, we're gonna keep yellow and violet under 6, right? Nice. Okay, I think I have shown you enough of the standard library functions for the collections. Let's go back to the slides and see what else we have there. So scope functions is the next interesting thing. And tell me how confused you are when you have to select one of them. Just nod. Yeah? Okay. They are very similar, but it's because, well, you just basically have this map, and we have it in the documentation, the mapping for every function, what it accepts and what does it have as a parameter inside the block that it is invoking. So it comes down to this scheme. Either the result of the function will be the original object, the x that I'm using to invoke this scope function. Currently scope function foo is one of those, let, apply, also, and so on. And then the parameter to the lambda, either the scope is limited to the implicit this, so everything inside this block is actually happening within the receiver, the x itself, or we use x as a parameter and then it's it. It doesn't mean that in the language you cannot use both, so it might happen that you will have this and it both inside the scope. This happens pretty often, but for those scope functions, this is basically what you have to keep in mind. But the difference is in the intent. So the intent is how you use, and for each situation you use the function. And I have a few examples. I will not start typing them because we run out of time. But one of the interesting idioms that you can use, or like the patterns that you can use or implement using the scope functions, is, for instance, this. You have an object, then you need to assign some properties, some values, and then you have to, you don't have any constructor for this object. For instance, basic data sources is a common example for this kind of things, because it just has an empty constructor and all the writable fields. Then you have to repeat the variable in order to assign to each property. And actually using the apply function, you can scope all the initialization within one block. It makes the code quite readable, I would say, and it returns the original object. Right? The result is the original object that we are calling it on. So it's quite convenient, and I see a lot of code like this in Kotlin projects. If you go and look up into the implementation, you will see that it's the implementation is very interesting. It's an inline function. It's a generic function, basically meaning that you can invoke it on any type. And there is a block of code, like the lambda itself, which uses this interesting syntax for lambda with the receiver, or functional literal with the receiver. If you go to the documentation, it's defined there as functional literal with the receiver. It's actually the central language feature for the implementing all those functions. And if you read up further in the documentation, you will see the mention of DSLs, the domain-specific languages, or builders, the types of builders. And this is the single most important language feature that implements all that. The let function, the other one, is very often confused with null safety operator. So people, when they start programming Kotlin, they figure it out. It seems to be a pattern to use the null safe operator along with let. But in reality, those are two different things. One is the operator from the language, and the other one is the function from the standard library. But because they are used so often together, people confuse it as a single operation. And well, here's an example how to use it, right? We retrieve some object from somewhere as a result of the operation, and then we check for a null, and then we use this object to refer to some property of it so that we don't get null pointer exception. Very legit code, and I would say I would prefer to see this kind of code instead of using the let operator. But because people, when they discover new things, they start using those and writing this kind of code. And the anti-pattern here is that if you write let, it means that you don't care about the opposite situation, right? So if you want to perform some operation only if the object is not null, but maybe it's like in real life applications, maybe it is interesting why the order is null. That's an exceptional situation, and you need to log that. So be careful with this kind of code. Instead, a more interesting pattern, I would say, that our compiler engineers shared to me is this. You have some complex expression that returns a result, and then you use the let function as a gate for some condition. For instance, here we check if the result of this expression is of some type, and because we have smart casting, then we can check the some internal property of that object of that type as well. So just to show you how it may look like with real types, we retrieve the order and we check if the order is actually a subscription, and if that order of type subscription has a customer with name Anton, then we do something else, apply the discount maybe. Why not? It better be hard-coded. Okay. Here's another example of a weird situation, like how you would not write the code, but maybe when evolving the code, you will see this kind of things happening. So this is a real code from a real project. Those who know the standard functions already and read this code, they will immediately see that it seems to be an overkill to use the let function there, because it seems like you could have just created the file from the path and then applied the also function without using the let function. But maybe it was just evolution of the code. The code was refactored, some code was added, some code was removed, and then they ended up with this kind of code at the very end. Not a great excuse, I know, but maybe it just happened. So it would be much simpler to write this code here in this situation if we had to write exactly the same functionality. Everybody can read and understand it, right? But there, of course, are like legit uses of the scope function for this case, because here we are creating a file or a directory or whatever, and then we have a side effect. And the also function is very useful for expressing the side effects. I want to do this and also do something else. In my programs, when I just write demo code, let's say I have like multiple lines and I suddenly want to log everything on every line, then using also function is very useful. You just go at the very end of each line, like you can multiply the cursors and write them like at once, and then deleting them is also very convenient. So debugging with system out print lines is a common thing. Let's talk about builders a little bit. So I said we have a lot of them in the standard library function, in the standard library, and they are implemented usually as functions to build something. If we go to the IDE, we have this build, and you'll see build list, build string, build map, build set, and so on. And if you go into the implementation of any of them, build string, for instance, append whatever, append something, append line. Hello. If you go to the implementation, you will see that there's almost always the apply function. You will find it, and that's the central piece or central feature for implementing the builders, right? Not the apply function itself, but the lambda with the receiver, of course. But apply function is just the tool for that. Obviously, not only strings you can build with the builders. Let's say I want to build a list, and if I just type it like this, you can see that the IDE is yelling at you that you haven't specified the type. So you're like, okay, I have to do that. Okay, I'm adding the string. Now I satisfied the compiler, but at the very end, I wouldn't like to have this parameter because I'm just building a list of strings. Why would I have to specify it? And therefore, in the compiler, we have builder type inference, and depending what you type inside the lambda block, or depending on how you use the result, there will be a type inference kicking in and allowing you to not to specify this type parameter. So something like this: list of strings, like this. Oh, I'm getting better at typing. Or if I don't specify the type on the left-hand side, it's also compiler error again. So what can we do here is start contributing to type inference. For instance, I want to get a first element for whatever reason. Here, the type of that X is not known yet, so there's no information on the variable declaration side in the parameter for the build list function. We cannot derive what kind of type we are going to get from that list in order to do something, and therefore it's a compiler error. So type variable, we don't know the type. But as soon as we say that it's actually a string, the compiler will be happy, and the type inference will just go over a few stages and say, okay, you actually have a list of strings as the result. The other way that is more common when you are building something is to add the result, of course, or add the value, and as soon as we specify what value it is, the compiler will kick in type inference again, and obviously we don't have to specify the type parameter for the invocation or integer, for instance, right? So because this is the builder, like the lambda here is, let's keep the string, because this is the block of code that where we can basically write any logic. We can write a loop, for instance, like for whatever range, like 10, and generate some values, ei in, and say I want to do this, like this, right? Or we can use any standard library function for the same, repeat, I don't know, 10, and just start adding the same things into the builder. So meaning that you can write any imperative code inside Lambda, right? And because we are adding elements, it means that the scope of the list that we are working with is like we are working within the scope of a mutable list. But as soon as we get out of this builder, we get an immutable list. So that's an interesting thing to notice here, so that mutability is scoped into one place, right? Not scattered across the project. I hope I have a few other minutes to show you something. Builders are actually not only in the standard library, but if you start using some other libraries for Kotlin, you will see some interesting uses of that as well, or patterns. You will see, let's say, in Kotlin X HTML library that is, designed to generate the structured documents. You can see all the same patterns again. You have like some function invocation, a block of code, inside that block of code, the other block of code, and so on. Ktor, you will see the same pattern again, like some interesting builders, and so on. And as I already said, like one thing to remember from this presentation, this is the most important language feature for all the standard library functions. Let me skip over the DSLs part that I was using to demonstrate the same concept, and just a few extras that we have in the standard library that are not immediately obvious that they exist. For instance, we want to filter a list of objects, and the list of objects contains any kind of objects, meaning the common supertype is any. And well, one thing to do is obviously checking for the type, right? Using the is operator, or if you're coming from Java, that's basically the same as instance of operator. There is a standard library function called filter is instance that is parameterized. The difference here, like it seems that you're not winning much here. Like this is the same line, just even more characters for that function. The value of using this function is that the result will be of the concrete type. So instead of getting the list of any objects after this operation, you will get the typed collection. The other interesting way, like the standard library function, or the feature, I would say, is that you can use CompareBy function to create comparators, and then it's applicable for comparing objects by multiple values and keys and properties. So if I had to implement the comparator for the two-person instances, right? First I want to compare by name, and then if the name is the same, compare by age. And with the standard library function, it just boils down to this invocation where we use the CompareBy function and refer at the properties that we want to use for the comparison in the order of preference. The other similar function here is the GroupBy function. So for instance, we want to group the requests into the map, and then, well, GroupBy and some property will do the same for you. Just much shorter version of the same code. And another very interesting function, I think it's undervalued and not very known, is the coerce in function, where you have to implement the logic of buckets, like bucketing the value into some range. For instance, if the value is less than 0, if it's -1, then let it be 0. Then if it's over 100, let it be 100. We truncate the value lower to 100. And then if it's between 0 and 100, then let it be the same value. And this is the behavior of this coerce in function, that it basically shrinks the value into the given range. I hope it wasn't the time wasted for you and you learned something. Can you give me a hint if you learned something? Perfect, nice. Thank you very much for inviting me and for listening. If you want to get the slides and the code samples, maybe, I will put them up into the speaker deck, or otherwise you can reach me out on Twitter. My DMs are open and I'm always happy to answer. Thank you.
Anton, thank you very much. You can stay for a couple of minutes. We have some time for questions if there are any from the audience. Yeah.
Thanks. Super nice talk. Maybe from top of your head, if you know iterable and collections, why iterable is extra interface comparing to Java? Or maybe you know example which is iterable but not collection.
I'm not sure 100% if the example they tell you is iterable, but maybe it is. I have to check. My assumption is like. Sorry? Arrays could be. So basically, you can actually implement any type and say that's iterable, and then use the for loop to iterate over that type. And as I said, I'm not 100% sure if that's a correct example, but iterating over the incoming frames from the WebSocket channel in Ktor, for instance, you can write a for loop there and supply a channel as the range, but it doesn't. It's not a range. So maybe if I check, it will be implemented as iterable, maybe as something else.
So you're saying there is a collection you have to size. There is size, and for iterable there are no size. If I'm correct.
That's a good assumption. I don't know.
Okay, thanks.
I have to check. I have to think about it a little bit. Yeah.
Any other questions?
Yeah, I'm still here at the break, so.
Exactly. So you will find him.
Mhm.
Yeah. Thank you
Thank
so
you.
much.